Hi students, today I am going to explain magnetism lesson. So we all know what are magnets. What is a magnet? A magnet is a substance that can attract objects made of iron, nickel, cobalt or their alloys. So we can say what is magnet? A magnet is a substance that can attract objects made up of iron, nickel, cobalt or their alloys. So what is magnetism? This property of magnet to attract such objects is called magnetism. So if they ask what is magnet, you should write this, and if they ask magnetism, this we should write. The property of a magnet to attract such objects is called magnetism. So what are magnetic and non-magnetic substances? Let's see. So what are magnetic substances? Substances such as iron, nickel, cobalt or their alloys will get attracted to magnet. Whatever is a substance, if it gets attracted by a magnet, it is called magnetic substance. And if it is not get attracted by a magnet, it is called non-magnetic substances. For example, plastic, wool, wood, paper, rubber examples are non-magnetic substances. Let's see one activity. So let's see this activity. So for this, we want materials like a magnet and some common items we use in home like pencil, metal, pen, paper, rubber, ruler, iron nails, plastic toys, safety pins, copper wire, etc. So now what we have to do, we have to place all these in a plastic tray and we have to bring a magnet close to each and record the observations. We can see some objects will get attracted and some will not get attracted. The things which get attracted to the magnet are called magnetic substances and which will not get attracted by the magnet are called non-magnetic substances. We can just write the magnetic and non-magnetic substances separately. Now, what are natural and artificial magnets? So natural occurring rocks like lodestone, magnetite, these has the ability to attract magnetic substances. So they are called natural magnets. After a long time, people also learn to prepare the magnets. So which could be artificially made by human are called artificial magnets. Magnets that are made by humans are called artificial magnets. They came in different shapes and sizes depending on the purpose for what they are used. So most commonly used magnets are bar magnet, a horseshoe magnet, a ring magnet, disc magnet, like this. So let's see what are the properties of a magnet. What special properties these magnets have? So if we think of magnet, we think of first of its property, attractive property. It will attract the iron, cobalt, nickel like things. So the first property of a magnet is attractive property. A magnet will attract magnetic substances by experiencing some force. What is that force? Is called magnetic force. And the region around the magnet have some that force, magnetic force, and it can experience this force. That's why it is called magnetic field. The region around the magnet will have some force called magnetic force and that field is called magnetic field. Then we will see one activity so that the poles of a magnet are there or not. So next property is poles of a magnet. First property, attractive property, I already told. Next is poles of a magnet. It have two poles, north pole and south pole. To find this, we will see the activity. So what are the materials required? A bar magnet and some iron fillings. So we have to sprinkle the iron fillings on a piece of paper and move the bar magnet randomly on these fillings. We can see these iron fillings are mostly at the ends of the bar magnet. So we can say that at the ends it have more magnetic property than at the middle. So the ends will attract the most of the iron fillings and these ends are called poles. What they are called? Poles. So we can say that each magnet will have two poles. What are they? North pole, south pole. The attractive power of a bar magnet naturally will reduce from the ends when it comes to the center. Means in the center there will not be there any attraction. Practically zero attraction will be there. At the poles maximum attraction will be there. Then next property is directive property. It will direct which direction we are seeing. When we suspend a freely suspended magnet, when you suspend a magnet, It always points, the north pole will show geographical north, south pole will show geographical south. So we can know the direction with the help of these magnets. The pole of a magnetic pointing towards the geographical north is called north seeking pole or just north pole. The pole of the magnet pointing towards the geographical south is called south seeking pole or just south pole. So every magnet, whatever is its shape, it has both north pole and south pole in this. So we can use this as a compass. We know what is compass. A compass is a simple device to use. It is used to show the direction. So a magnetic compass is a simple device that it shows a directive property of a magnet. It consists of a small flat magnetic needle balanced on a nearly frictionless pivot. So the north pole of the needle is marked with red color. See here. It is then enclosed with a flat aluminium case with a glass cover. And so directions such as northeast, because between north and east, northeast, east, then southeast, because between south and east, southeast, south, west, west, and between south and west, southwest, and then north, between west and north, so northwest, like this they are pointed. And the magnetic needle is very free to rotate about its center, and it always points in the north south direction. It is primarily used for navigation purpose. Then to verify whether the magnet always points in the north south direction, simply take a bar magnet and some thread and a stand. For this procedure, tie a thread to the stand in the middle of the magnet and allow the magnet to come to rest by tying here. On the base of the stand, mark a chalk line along the length of the magnet to show its resting position. So now disturb the magnet again. Again it will come to rest. How many times you will do? The same, the north pole will come on the geographical north and south pole will come on the geographical south. So this tells that it will always show the direction. And then magnetic poles always exist in pairs. What it means? Always it will have two poles. It will not have only one pole. Whatever is the case, it will always have two poles, exist in pairs. If a bar magnet is broken also into two or more pieces, again it will have two directions. So it is impossible to obtain a piece of magnet with only one pole. It always have two poles. Remember this. Then we will see attraction and repulsion between two magnets, how it will occur. So they gave an activity. So to find out like this, we have to suspend one bar magnet, same. Yes, no, and take one more magnet. So two bar magnets are needed for this with marked poles and a stand and some thread. Suspend one bar magnet from the stand with the help of the thread and bring the south pole bar near the north pole. So opposite poles. So bring south pole to the north pole. We will see attraction there. Again north pole to the south pole. Again there will be attraction. Bring north pole of the magnet to the north pole. Same poles, it will repel. And south pole of the bar magnet near the south pole of freely suspended bar magnet. Again it will repel. From this we can know one thing. Like poles will repel. If we take north and north, it will repel. South and south, it will repel. But if we take opposite poles like north pole to south pole to north pole, then it will attract each other. So from this we came to one conclusion. Unlike poles attract and like poles repel each other. So then we will test for a magnet. You know very well that a magnet will attract magnetic substances and opposite poles of the other magnets will attract. Now we will see. Now we test if a metallic bar is a magnet or not. See here. In this what we want? An unidentified metallic bar. We don't know whether it is a metal or not, and an unidentified metallic bar and a bar magnet. So keep the unidentified metallic bar on a wooden table. Take a bar magnet and bring one of its pole close. If a bar is not attracted to the magnet, it means the magnet bar is not a magnetic substance. It is a non-magnetic. If the bar is repelled by the magnet, then it is a magnet. So if the bar is attracted also, it is a magnetic material. If it is not showing anything, means it is not repelling, it is not attracting, or if it is not doing anything, then it is not a magnet. So if the bar is repelled, it clearly shows that its end has same pole as the end. So we can find out the poles also by like this. Because opposite poles attract and same poles will repel. Then, so repulsion is the surest test for magnetism. If we want to test a magnet, repulsion is the surest test. And then see the bar magnet. Magnetic north pole near the end of the freely suspended bar magnet, that shows the geographical north, and south pole, it shows the magnetic south pole, which shows the geographical south pole. Then magnetic equator, it is the equator PQ, an imaginary line drawn bisecting the effective length of the magnet in the equator. Then magnetic axis XY, like this, it is an imaginary line passing through the magnetic north pole and magnetic south pole, and it is called magnetic axis. Then we will see what is magnetic field. So we know that a force is exerted by a magnet and it is called magnetic force, and it is a non-contact force. Without contact, without touching it only, it will have some force. So it will have magnets, if we keep far also, it will attract. So it will act from a distance also. So depending on various factors, each magnet has certain region around it. So around the magnet some force will be there. So on the other magnets or magnetic materials, that force is called magnetic field. The strength of the magnetic field of a magnet decreases as we move away from it. When it is little closer, the strength will be more. When it will move away, it will be less. So a magnetic field is represented using curved lines. We can see here curved lines is called magnetic lines of force. Conventionally, magnetic lines of force are considered to originate from North Pole. So it is starting from North Pole because the arrow see here, it is going to South Pole. So it originates in the North Pole and goes to the South Pole. So like this curved lines, they are showing by indicating arrows. When two magnets are placed close to each other, so what happens? The magnetic force between them can be represented using magnetic lines force. See here bar magnet, how it is there. From North Pole, it is the magnetic force is starting and ending with South Pole. So curved lines here also same. You can see the curved lines in a horseshoe magnet, and magnetic lines between two magnets and like poles will be creating with each other. When like poles repelling, see how they are repelling with each other. So like this we can see. From this we will see some properties of magnetic lines of force. These are continuous curves. Magnetic lines of force are continuous curves. Outside a magnet, magnetic lines of force begin from North Pole and it ends in South Pole. It always starts from North Pole and end in South Pole. However, inside the magnet, direction from South Pole to North Pole. From outside, if we see, we can see it starts from North and ends with South. But inside, it will start in South and end with North. No two lines of force ever intersect at a point. No two of the lines, never it will intersect with its other. So, densely populated lines of force indicate strong field. If there are so many lines are there, densely populated means strong magnet. Widely distributed lines, if the lines are very far away, then weak magnetic field. Magnetic lines of force show the direction of magnetic field at each point around the magnet. It will show the direction of magnetic field around the magnet. Then see the magnetic field of a bar magnet. A sheet of white paper is needed, a bar magnet and some iron fillings. Place the sheet of paper on a wooden table and place the bar magnet in the middle of the sheet like this and sprinkle some iron fillings. Tap the paper gently. We have to tap it gently. Then we can see like this, the iron fillings rearrange themselves and the curved lines are formed. Yes. Next activity is to plot the magnetic lines of force of a bar magnet.